Hi there, and welcome to tutorial 18, which is a video on trigonometry for the purposes of the Core 3 Edexcel Maths A-Level. It's our 9th video on that to date. As always, for more help with your GCSE or A-Level Maths studies, do see the YouTube channel or website. To start with, everything in green we've done in the previous 8 videos. What we're doing in this video is finishing off trigonometry, and here we are considering expressions a cos theta plus b sine theta, and we're going to write it in different forms, namely r cos theta plus or minus alpha or r sine theta plus or minus alpha. And hence, students will be able to solve a different set of equations. A cos theta plus b sine theta is equal to c. Before I launch into this topic and how to do the various aspects of it, I want to start off by looking at some graphs to give you the bigger picture here. So I'm going to go to some software called Autograph that draws graphs out for us. I'm going to start by drawing a graph. I'm going to draw the graph y is equal to a lots of sine theta plus b lots of cos theta. I'm going to start by making a and b equal to 1. So really I'm drawing the graph y is sine theta plus cos theta. Maybe take a moment to think of what you think that graph looks like. Okay, let's let Autograph plot it. Now, this graph here, as you can see Autograph plotting it, has the wave-like function of a sine graph or a cos graph. It looks rather like one of those. Some differences. It goes above the value 1. It goes to about 1.3 or 4, and it goes down to negative 1.3 or 4. A sine graph stays between 1 and minus 1, and so does a cos graph. But that's because we're adding together sines and coses. But generally, it seems to look like either a simple sine graph or a simple cos graph. Okay, let's look at its period. An easy way to do that would be to ask Autograph where its roots are. And let's say I compared that root there to that root there. Here the graph is coming up to a root and going positive. Here is the first time it again comes up to a root and goes positive. If I looked at the distance between that root and that root, the theta distance between that root and that root, that would give me the period. Looking at what Autograph says, that point there is at 5.498. That point there is at negative 0.784. If we take that number and subtract negative 0.7854, we get 2 pi. Which is the period. So just like a sine or a cos graph, it has a period of 2 pi as well. That's its period. I'm going to just say p is equal to 2 pi. Okay, let's just check it's not because I've chosen a and b to be 1 that it looks like a sine or a cos graph. Let's move around a or b. So I'm going to move a around in units of 1. That just stretches it upwards or makes it go downwards negative. So that still looks like a sine or a cos graph. So I'm going to put a back to 1. And if I change b in steps of 1, again it's got the wave-like properties there. So it could look like a sine or a cos graph. Okay, interesting. Well, let's put b back to 1 as well. It seems to me that this graph here looks like a sine or a cos. So I'm going to rub out this graph. I'm going to delete this graph here, and I'm going to start over with a particular new graph. The new graph I'm going to start over with is y is equal to, let's say, 3 sine theta plus 4 cos theta. And I'm going to draw that graph. Now just take a second to think to yourself what that looks like given what I've just talked about. But let's let Autograph plot it. And as you would have hopefully realised, it again has the wave-like properties of a sine or a cos graph. and it's looking like this here. It's going all the way up here. It looks like it's meeting at 5 and it's coming all the way down here to -5, but it's got that wave-like property of a sine or a cos graph. Now the next thing I'm going to try and do is I'm going to try and make a sine graph fit into this. So I'm going to draw myself the graph y is equal to some number r, lots of the sine graph, but sine of theta, let's say plus alpha. Okay, now r will help me stretch the sine graph up or down, and alpha will help me move the sine graph right or left as appropriate. I'm going to start by making alpha to be 0, and I'm going to let r be 1. So really I'm drawing y is equal to sine theta. You should know what this looks like, but let's plot it. And I'm just going to fast forward that on. You should know that's the sine graph. Okay, the sine graph goes up to 1, down to -1. It looks something like this. Now, can I change r and alpha to make it fit that? Well, let's have a go. I'm going to move r up in steps of 1. That's stretching upwards like I want. R is 3. R is 4. R is 5. That seems to be exactly the right height. Can I change alpha now to make it move backwards so it's exactly in line? So let's go to the alpha constant. Let's see if we can move it to make it exactly in line. If I decrease alpha, alpha is currently 0, if I make it negative 0.1, negative 0.2, I seem to be moving away. So I need to make it positive. So because I want to shift it in that direction, so I'm going to make it positive, 0.1, 0.2, 0.3, 0.4, keep going, 0.8, that's close, 0.9. It's not exactly right, but 0.9 is a half decent guess. So I've drawn the graph y is equal to 5 sine, and I've done theta plus 0.9. Remember, it's in radians. Theta plus 0.9. And that has given me the same thing, or virtually the same thing, as the graph y is 3 sine theta plus 4 cos theta. Okay, I better try and do it with a cos graph as well. So I'm going to start off with a new graph here. I'm going to draw the cos graph. Y is equal to some number lots of cos. So we've used r, so let's say p lots of cos theta, and this time we've used the constant alpha, so let's use plus beta. Okay, can I find a p and a beta to make the cos graph fit perfectly? I'm going to start with beta to be 0, and I'm going to start with p to be 1. So I'm drawing the y is equal to cos theta graph. And the computer's doing that for us, but I'll whiz it on. The cos theta graph looks like this. Let's try and change p and beta so that it fits perfectly within the original graph. So I'm going to increase p first of all in steps of 1. It's currently at value 1. I'm going to make it bigger. 2, 3, 4, and again 5 seems to work out perfectly. Now I need to change the beta. I want to move it that way, so I'm going to have to make beta negative, because if I make beta negative, it shifts the graph in the right direction, the positive theta direction. So beta, I'm going to make to be negative this time. It's currently 0. I'm going to make it reduce in size by 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 is close. It's not great, but it's close. So I have also now drawn the graph y is equal to 5 cos theta, cos of theta minus 0.7. And that is virtually like my original graph, 3 sine theta plus 4 cos theta. It almost fits in. So what this demonstration has showed me is that some lots of sine theta plus some lots of cos theta, a graph of that, well, I can write it in the form, I can write it as a single sine graph transformed it in the y direction and shifted appropriately in the x direction, or I could draw it as a simple cos graph stretched upwards in the y direction and transformed appropriately in the x direction. So that's the whole idea of this concept here. So going back to our lesson here, is that any trigonometric expression of the form a sine theta plus b cos theta, so some lots of sine plus some lots of cos, any expression of that form can be written in either this form or this form. The way I showed that on the demonstration was that I showed any graph that looks like that can be also written as a simple cos graph stretched appropriately in the y direction and shifted appropriately in the theta or x direction, or can be fitted exactly with a sine graph stretched appropriately in the y direction or shifted appropriately in the x direction. And what we found was our particular example, we showed that this graph 3 sine theta plus 4 cos theta, we showed that was the same as the graph 5 sine theta plus 0.9 radians. Okay, so that's the big idea. Anything that looks like that, multiples of sine and cos, can be written as a single cos or a single sine with an appropriate y direction stretch and x direction translation. Right, time to do some examples and show how to get this without the autograph software. In order to be able to do this, we have to remember what the addition trigonometric formulae. Okay, so I'll just give you a moment to see if you can remember what these formulae are. And I'll show them to you. Hopefully you can remember these, but these are given in the formula booklet. These formulae here, check these off. Hopefully you remember them. But the ones we're going to need is this one and this one. These are going to help us in the work we're going to do for the r cos theta plus or minus alpha form, or with the sine. Right, to do this, let's start with an example. We're going to show, algebraically this time without autograph, that you can express 3 sine theta plus 4 cos theta in that form, r sine theta plus alpha. Well, we have to find r and we have to find alpha. This is the example I did on autograph. So, let's start by saying what we know. We are told that 3 sine theta plus 4 cos theta can be written or is equivalent to or is identical to r cos theta plus alpha. Oh, sorry, r sine even. Okay? Now, the only thing we could do here, we could try and expand this using the addition formulae, because we know a formula to expand that up here. Sine A plus B is sine A cos B plus cos A sine B. We could use that formula with A the same thing as theta and B the same thing as alpha, and we could expand it. So let's give it a go. I'm going to keep R out the front for now and expand this using the double angle formulae. So just expanding this, okay, with A the same thing as theta and B the same thing as alpha. And with a bit of luck we would get the following: sine theta cos alpha plus cos theta sine alpha. And multiplying everything through by the r, that would give us r sine theta cos alpha plus r cos theta sine alpha. And we know, we've been told, that this will be equal to 3 sine theta plus 4 cos theta. So what can we do now? Well, we could be very clever and we could notice the following. I've got sine theta here, and I have a sine theta this side. To make sure both sides of this identity have the same numbers of sine theta, it would have to be true that 3, that's how many sine thetas we've got on the left hand side, was equal to r cos alpha. If that was true, we'd have the right number of sine thetas. And we could be clever and do the same thing with cos theta. In order for this identity to work, it must be true that 4 must be equal to r sine alpha. And we've got two simultaneous equations that we could find the r and the alpha that make these two true. If we did, we've then found the r and the alpha to have this expression in the right form over here. Right, how do we solve something like this? Well, we could be very clever. We could say, imagine you took equation 2 and you divided it by everything in equation 1. What would I get? Well, 4 over 3 would be equal to r sine alpha over r cos alpha. So how does that help? Well, the r's cancel, and sine alpha over cos alpha is tan alpha. So we'd have 4/3 is equal to tan alpha. And now we could find alpha. Alpha must be the inverse tan of 4/3, which if you type in your calculator, keeping your calculator in radians mode, inverse tan of 4/3, you get 0.93 to 2 decimal places. So alpha is 0.93. We have found an alpha. Okay, could we find r? Well, we could. We could find r by substituting this alpha up here, and that would also work. Perhaps slightly better than that. I'll do an additional bit of working because this just going to do some extra working over here. If we squared equation 1 and added the square of equation 2, what would we get? Well, on the left hand side we get 3 squared plus 4 squared, and on the right hand side we'd get r squared cos squared alpha plus r squared sine squared alpha. And 3 squared plus 4 squared is 25. We could factorise out the r squared from both. R squared, I'd get cos squared alpha plus sine squared alpha. I know cos squared plus sine squared is 1, so I'd have r squared is 25, and r, which I've chosen must be bigger than 0, is therefore 5. And this would be working underneath that. So to finish with then, you have answered the question. The final answer to the question is that this here can be written as follows: 5 sine alpha plus 0.93 radians to 2 dp. And we have found what we did on the graph method using algebra. And that's a very typical exam question. Now, I'm going to take a moment to show you the step-by-step procedure. You can copy this down. This is for a general question. If you are trying to express the following in either of these forms, these are what you do. The first thing you do is you write out the appropriate identity. You say that a sine theta plus b cos theta is whatever they tell you in the question, either r cos theta plus alpha, or r cos theta minus alpha, or r sine theta plus alpha, or r sine theta minus alpha. They usually give you that, and you write it out. Then what you do, you expand the right hand side. That was the right hand side. You expand this here, the right hand side, and you write two equations for a and b, equating them to the trigonometric expression on the left hand side. So as we did before, we worked out what a and b had to be, and we wrote down two equations. Step 3, you can always get r, and r always turns out to be the square root of a squared plus b squared, as it did in this example over here, back there. R was the square root of 3 squared plus 4 squared, which was 5. Lastly, you divide the two equations you've worked out in step 2, and you get an equation with tan theta. You solve it to find theta. The last thing you do is you write out your correct answer with the r you found and the alpha you found. Sorry, I just realised that should have been, you get an equation with tan alpha, sorry, and you solve it for alpha. And make sure your alpha is in degrees or radians as appropriate. So they're the steps. Let's have a go at doing more examples. Here we go. Show that we can express this expression in this form. Basically, we have to find r and we have to find alpha, and then we've got to sketch the graph. Okay, step 1 was to write out the identity they give us. So sine x subtract root 3 cos x must be identical to, and we're told, r sine x minus alpha. Step 2, I said expand the right hand side. So this is equal to, once we've done that, we're using this here, but we're using the minus version, the negative version, so it would turn out to be r sine x cos alpha subtract r cos x sine alpha. And we know that's sine x minus root 3 cos x. Clearly then, we can say that r cos alpha must be equal to 1. There's a hidden 1 here. So our next line would be that r cos alpha is equal to 1. And we could also say that we've got a minus in the right place, so that's fine. We could also say that r sine alpha must be equal to root 3. So r sine alpha must be equal to root 3. That is equation 1. That's equation 2. Next step, I always said r turns out to be the square root of a squared plus b squared. A is 1 and b is root 3, so 1 squared plus root 3 squared. It always turns out to be the case, and in this case, therefore, if you work that out, r would be 2. Done. And how could we then work out alpha? Well, if we divide equations 1 and 2, so divide 2 by 1, we would get tan alpha is equal to root 3 over 1, which is just root 3, and alpha is therefore the inverse tan of root 3. And keeping our calculator in radians mode, if we do the inverse tan of the square root of 3, we should get ourselves pi by 3. So alpha is pi by 3. So what's our final answer? Our final answer then is that sine x subtract root 3 cos x is actually the same thing as 2, because we've got r being 2, sine of x subtract pi by 3, of x subtract pi by 3. If we're trying to draw that graph, okay, let's draw that one instead, because that's a simple transformation, stretch in the y direction and a shift in the x direction. What is it? Obviously, it is stretch by a factor of 2 in the y direction, and it's a shift right by pi by 3 in the positive x direction. So I always find it helpful. I know this here is comes from a normal sine graph, but I draw the normal sine graph to start with. So the normal sine graph looks something as follows. And I always mark the key points in. This point here is 0, this point here is pi, this point here is 2 pi, and minus pi, and minus 2 pi. This point here is pi by 2, this is 3 pi by 2, etc. And I'm going to draw myself the transformed version. Now, it's kind of like this graph in the sense that it would be like that, but it's shifted over pi by 3. So it has roots, it will have roots here, here, and here, here, and here. So it'll have the roots there, but it will shift up by a factor of 2. So it will go up to 2, down, and it goes as follows. Okay, can we fill in these points here? Well, we can. That is the point pi by 3. That was at pi before, but it's at pi plus pi by 3, so it's at 4 pi by 3. This point here was at 2 pi plus pi by 3, so it's going to be at 7 pi by 3, etc. Could we find the coordinates here at that point? Well, we could, because that is when, in this equation, x is 0. So we could just type in our calculator 2 sine of negative pi over 3. Let's see what we got. And we get negative root 3. So this is the coordinates 0, negative root 3. And hence we've drawn that graph there. Okay, let's keep going with a couple more examples. Example 3, we want to express this in this form and hence solve an equation. Right, step 1. You could have a go at doing this bit yourself actually now. You should be able to have a go at that, so maybe pause the video, have a go, otherwise I'll go through. We want to say that 2 cos theta plus 5 sine theta, we're saying that is identical to r cos theta minus alpha. For some r bigger than 0, alpha between 0 and 90. I'm going to use the cos addition formula, but the subtraction version. So this is going to be equal to r cos theta cos alpha plus r sine theta sine alpha. Okay, so equating these two things together, what can we say? Well, we can say that, how many cos thetas have we got? We've got 2 cos thetas, so 2 must be r cos alpha, so 2 must equal r cos alpha, and similarly 5 must be r sine alpha. There's our two equations, equation 1 and equation 2. As always, r is the square root of 2 squared plus 5 squared, which is 4 plus 25, so it's the square root of 29, so r is the square root of 29. And how do you find alpha? Well, you do equation 2 divided by equation 1, you get that tan alpha is equal to 5 over 2, so alpha is the inverse tan of 5 over 2, which if this time your answer is in degrees, so alpha, put your calculator in degrees mode and do inverse tan of 5 over 2 and you get 68.2. So you get 68.2 degrees. Okay, so therefore this thing here, so 2 cos theta plus 5 sine theta is therefore the same thing as root 29 for r cos of theta subtract 68.2 degrees. Okay, and we have done the first part. It then asks us to solve an equation. Right, I'm going to just copy this here. We've got that from our previous working, and we are asked to solve the following equation. I'm just going to write this underneath it. We're asked to solve this equation here. Now, obviously, we've done the first part. We have worked out an expression for this. We've done that because maybe solving this expression equals 3 is easier, and it turns out it is. So solving this is the same thing as solving the square root of 29 cos theta minus 68.2 degrees, okay, is equal to 3. It's the same thing as doing that. So how would you solve something like that? Well, the first thing you do is you divide both sides by root 29. So cos of theta minus 68.2 degrees would be 3 over the square root of 29. And then your principal value, theta minus 68.2, would therefore be the inverse cos of 3 over the square root of 29. So type in your calculator with your calculator in degrees mode, inverse cos of 3 over the square root of 29. And you get the answer 56.14. So you get that theta minus 68.2 degrees is equal to 56.15 degrees, or 68.1 degrees, let's say. Now we have to find all the other values. Now we draw a normal cos graph. We're going between 0 and 360. You actually extend your range on a little bit here to minus 68 because you're going to add 68 at the end, but let's continue with that. So the cos graph looks something like this. This here's 90, this here's 180, 270, 360. And you have found that your answer is 56.1, so it's somewhere here, 56.1. Now, we should have continued back this side as well, because also there will be an answer of negative 56.1 here. So I've got an answer of 56.1, negative 56.1, and also this is 56.1 from a top, so this here will be 56.1 back from the top, so 360 minus 56.1, it would be 303.9. So, therefore, theta minus 68.2 could be the following. It could either be negative 56.1, or theta minus 68.2 could be equal to positive 56.1, or theta minus 68.2 could be equal to 303.9. Now, then you add 68.2 to both sides of each equation here to get your theta values. Adding 68.2 to this side gets your value outside 360. So it doesn't get you one of the answers you want, but if you add 68.2 to both sides here, your theta value would be as follows. You get for the first one 12.1 degrees, and for the second one 56.1 plus 68.2, you would get 124.3 degrees, and they are your two answers. Okay, last example to finish with. Sometimes ones like these come up. Find the maximum value of 12 cos theta plus 5 sine theta. Give the smallest positive value of theta at which this arises. Now, looking at this here looks a multiple of cos theta and a multiple of sine theta. It must have an r cos theta plus alpha or an r sine theta plus alpha form. It doesn't matter which one you pick. Pick one of these and just make it work. So I'm going to say that 12 cos theta plus 5 sine theta. I'm going to say, because I want a plus going on here and I want a cos in the first one, I'm going to say, I'm going to use, it doesn't matter honestly which one of these you use, but I'm going to use r cos theta minus alpha. You could use any of them, and just be careful with the signs. If you expand that out, you would get yourself r cos alpha, cos theta cos alpha, and you would get plus r sine theta sine alpha. And then you could compare coefficients as we've done previously. So you could get yourself then the following. You could say that 12 must be equal to r times cos alpha, so 12 must be r cos alpha, and you would get yourself that 5 must be r sine alpha, so 5 must be r sine alpha. Using the normal thing, r is the square root of 5 squared plus 12 squared. Okay, so r would end up being 13, and you would divide these equations to get tan alpha is equal to 5 over 12. So you would therefore get that alpha is the inverse tan of 5 over 12. And if you work that out, the inverse tan of 5 over 12, you get yourself 22.6 degrees. And therefore, this thing here, therefore 12 cos theta plus 5 sine theta, 12 cos theta plus 5 sine theta is the same thing as 13 cos of theta minus 22.6 degrees. Now, working out the maximum of this is hard because it's a combination of cos and sine, but that's the same thing as working out the maximum of this. And you know that a cos graph, doesn't matter how it's shifted right or left, but a cos graph has a maximum value of 1. So this whole thing must have a maximum value of 13. Maximum, it says the maximum value is therefore 13. When does that happen? Well, it happens when cos of theta minus 22.6 degrees is equal 1. We better had solve it for theta. It asks us for the smallest theta where that arises. Therefore, theta minus 22.6 is the inverse cos of 1, which is 0. 0 degrees. So theta minus 22.6 is 0. So therefore theta is equal to 22.6 degrees. And that's the smallest value. It doesn't ask for the other ones. That gives this function a maximum value of 13. And we've done all the types of examples you can do with this particular topic. Therefore, to finish, I would suggest you read chapter 7, page 120 to 124 and look through those examples, and then do the whole of 7D on page 123 in your books. Then move on to the next video, which will be on a different chapter. Thank you very much for watching. I hope you found it useful in your revision.